Hey, Malmo. Good morning. Did I do okay? Was that pretty good? Good morning, right? Good morning, right? Tasamika, thank you so much for having me here today at the Øredev conference. It is my first time, but I must tell you that I am so happy to be here today. You know, walking through the fog, just feeling like I'm in this extraterrestrial environment, I feel like I'm right at home already. So thank you so much for that welcome. This year's theme, To Infinity and Beyond, it really captures the essence of exploration and innovation perfectly. Don't you agree? Yeah, I agree. And so the title of my talk, Innovating the Journey to Mars, is meant to take you on not just a journey through the cosmos, but a journey of human imagination and engineering. So, whenever humanity is about to take this great giant leap, we start with the question, what if? What if we could fly? What if we could walk on the moon? And what if we can call another planet our home? These are the very questions that has started humanity in the first place. Every ounce and step of exploration that we've done, we started with the question, what if? And so my journey started pretty similarly. At about the age of 11 years old, I decided to become an aerospace engineer. I know that you're asking the question of, how in the world did you know what an aerospace engineer was at 11 years old? Well, I wanted to be a designer, a mathematician, a scientist, an inventor, all of these different things. And it was an outreach program that came to my, what you would call your primary school. And it taught me the fundamentals of aerospace engineering. So I grew up in this small town called Mableton, in the state of Georgia in the United States. I always ask this question, but I think I know the answer. Has anybody heard of Mableton? No way. I don't believe it. Wow, that is amazing. Cool. We'll have to talk afterwards. But yes, I grew up in this small town, and I just dreamed of creating something special that could fly. My version of that was pink military aircrafts. It was quite specific and also kind of odd to see something like that flying in the air, but that was my dream. And so year after year after year, I fought towards that dream all the way to MIT. So MIT is the Massachusetts Institute of Technology. It's in Cambridge, Massachusetts, and it is known for aerospace engineering. So I felt like I was going to the right place, right at home. And I must say that going to MIT and then carrying on to the Artemis program, that was my journey coming into light. I dreamed of becoming this aerospace engineer. I wanted to make pink military aircraft. This became pink rockets. I know, that is even more absurd. But it made me think about curiosity. I had this inkling of curiosity growing up. I had it going through my schooling, and then I had it going through my career. And I realized that curiosity can take us one place, to infinity and beyond, right? I had to put it in there, I did. So, of course, when we're thinking infinity and beyond, it's not just a phrase, it's a mindset. Infinity and beyond is saying that there is a potential to go somewhere greater, right? So when you're in those moments and maybe the data isn't certain yet, or maybe the build isn't exactly where it needs to be in order to operate, maybe you have this vision that hasn't exactly come into fruition yet, but there's a potential to go somewhere. That is the mindset of infinity and beyond. So, you know, all of us, I can say that we have some slightly differing backgrounds here. With me being in aerospace, many of you may be in software, so you're working on different systems, you're working on different codes, you're working on different products. Whatever the case may be, we share that same innovation mindset to go to infinity and beyond. So let me tell you more about my journey. So MIT, I'm walking the halls of MIT as a young freshman, wanting to be an aerospace engineer. I already know what I want to do. I've thought about it since I was 11. I'm all set, right? And so I end up doing these different research opportunities, and I really found out what aerospace is really about. It's a humongous field, right? We're not just building rockets. We're creating systems. We're testing out different propulsion devices. We're doing all sorts of things. So as part of my journey, I actually did some research that would cause me to be in the lab until like 2 a.m. plus. And sometimes those products would work, sometimes they wouldn't. But in that moment, I was working on something so special. Has anybody heard of the biosuit? Yes, okay, I can teach you something. Okay, so the biosuit is a newer spacesuit for our future space exploration. David Newman, she was the deputy administrator of NASA at the time. That was her product. That was her prize. And I had the opportunity to work on that by trying to understand what is the best layer of material that we can use in order to thermoregulate our body, which is a fancy way of saying to sweat in space. It was a sparkling moment for me, and it was one of the pieces of research that enabled me to think deeper about aerospace. Beyond that, I was able to also look at different pathways to Mars. So yes, this is how I kind of came to this talk. I researched different pathways to get to Mars because at the time, we were going directly to Mars for the Artemis program. So I was researching, well, what could those pathways look like? What would that become? And well, I started to work on NASA's Space Launch System. Who is familiar with the Space Launch System? There we go. Yeah, so the Space Launch System, it is the primary rocket for NASA's Artemis program. The Artemis program, it is meant to get us to Mars, but first we step foot on the moon. So back in 2022, and I remember this year so tenderly because I was holding my youngest child as a newborn in my arms, looking up at the sky and seeing the rocket fly by while I was in Hawaii. And that was the moment that the first iteration of the Space Launch System launched. It launched, it did a rendezvous around the moon, it went through lunar orbit, and that was the first stage of what we would then deem as something that we're achieving that was previously impossible. Our first step inching towards Mars. So the Artemis program is not just this rocket launching and taking a loop around the moon. That is the first step. The next step is going to be crewed. It's going to have people doing that same route. The next step is going to be stepping foot on the moon. The next steps beyond that is building up a conglomerate to actually be able to live on the moon. The next step after that is enabling us to go to Mars. It's a process, right? And we just talked about to infinity and beyond, how you see a vision, there's potential, you take steps to get there. So step by step by step, I have been able to work on this product. I worked as a structural design and analysis engineer. Long story short, designing different segments of the rocket and then doing stress tests, if you will, in order to figure out if it's structurally sound to be able to navigate all of the forces that it has to endure during its flight. That was one of my roles. Another role, configuration management and product integration engineer. I had to verify and confirm that all of the different segments that are being installed on the rocket are in alignment with its design. So I was able to bring this vehicle down to Florida and overcome really strategic elements to get us there. With the process of engineering, you design, you build, you test, and improve. And this was the testament of that for my career. And so now, I am working on very cool aerospace innovation products today, but I will be talking about space. So I just talked about design, build, test, and improve. I wanted to bring in a rocket that may be more familiar for many of you. So who has heard of the Themis rocket? Yep. Okay. So if you have not, it's right in your backyard, you guys. It's right in your backyard. It's in Kiruna, Sweden, at the S-Range Space Center. I wanted to bring up this product because it is a testament of how you have to iterate when you're talking about engineering. And I'm sure that you can relate from a software standpoint as well. You design, you build, and you troubleshoot. We have to do that. Test and improve. That is the engineering cycle, but it's also, I believe, a philosophy for life. So whether you're in that stage of fixing the code that's not working, whether you're in that stage of trying to get this rocket to its destination, or whether you're in a place of trying to figure out where do I fit in this whole next generation of space exploration, design, build, test, and improve. So let's talk about it. The moon to Mars, right? So one common question that I always get, why are we going back to the moon? We've already been there. Why in the world are we going back? So the moon is truly our proving ground, is how I like to describe it. It is far enough so that we can operate independently, yet close enough so that it reduces risk. It reduces risk. It gives us the environment that we need in order to understand how humans can live in a deep space environment. And it provides all of these elements of familiarity as well. Since we have been there before, we have a really good understanding, compared to Mars, how we can operate in such an environment. And now we've only truly explored 6 sites on the moon, all near the lunar equator. And amongst those 6 sites, you can say that we've explored less than 5% of the lunar surface. So in the grand theme of things, we still have a lot more to explore. But we have taken the steps, the initial steps, in order to better understand the surface and its environment. So 5% of the moon is like saying that you touched down in Europe and you've endeavored an Earth exploration, right? Right? It's a very fragmented view of exploration. So we need to go and learn more. We need to form habitation to learn what to do for other planets, which brings me to thinking about how we did it before. So Apollo 17, that was the last time that we actually stepped foot on the moon. That was back in 1972. That's over 50 years ago. That's a long time, right? And so thinking about how we were able to do that endeavor, and also how we've been able to send different devices to the moon, it's time for us to go back. It's time for us to put our feet back on that lunar surface and prepare for what's next. So at this point, we have the advanced robotics, the imaging, and also the autonomous navigation in order to explore the moon like never before. So some of these products, they may look familiar. Some of them are newer. We've been able to send, of course, different rovers to the lunar surface, but then you also have some upcoming technologies such as the lunar outposts. You have different private companies such as Firefly that are creating different technologies to support our communications. So being able to communicate between the Earth, the moon, and maybe some other product that I'll tell you about in a second that will be orbiting the moon are all fundamental elements of what we need in order to thrive, to better understand what we're living on, what we're up against. So this is the lunar surface. You can see on the left there, the South Pole, you have these blue dots, if you will. Those blue dots are all indicators of water ice on the lunar surface. So what can we do with water ice on the lunar surface? Right? We can have drinking water made available. We can have rocket fuel. We can also generate breathable oxygen. These are all fundamental elements of what we would need to survive. Have we explored the South Pole? Not so much. So the foundation for the Artemis program, it is to go to the South Pole, explore that region, and set it up for humans to be able to live on. I also included a photo of the North Pole just to show that simply there are other water ice elements, but our focus is in the right direction, right? There's a much higher concentration at the South Pole. So why return to the moon? Is anyone familiar with the moon house? Yes. So I did some reading on this one. I found it to be quite fascinating. One of my friends, she actually works for JAXA, so she was a part of this mission. But there was a mission to send up the moon house to the moon. It is somewhere on the moon. We don't know exactly where, but we do know that it made it to its surface somewhere. But the answer to this is that we are staying. That's why we are returning to the moon. Simply put, we are staying. That is one thing that we have not done yet, and it's one thing that we will do. Another question that I get, will the moon be a pit stop to Mars? In some ways, yes. I like to call it a gas station, right? In a way, just to simply put it. I also like to call it a way to create a space that's a regeneration habitat, if you will. So you can go there, you can, like a regular gas station, you can get your fuel, you can get some snacks, reload on water, all of these different things. So in some ways, yes. But like I mentioned before, it's close enough to be a strategic stopping point on our way to Mars. Going to Mars alone from Earth, it takes approximately 7 months in duration just to get there. And then you have to wait for the orbits to align. And then it's another 7 months to get back. So in total, considering the orbital alignment, you're talking about approximately 2 years. So by no means at all with current technologies is it a short mission. It is a long duration mission. So it's important that we do have the necessary resources that we need in order to survive. Which brings me to Gateway. So Gateway, it's a lunar space station. I'm sure that most of you are familiar with the International Space Station. I view the lunar space station almost a carbon copy. And it will, of course, orbit the moon. So it's a modular space station, but I wanted to highlight a couple of elements that may be a little bit more near and dear to your heart because they are developed by the ESA, or the European Space Agency. One is the lunar IHAB. So the lunar IHAB is one of 2 habitats that will make up the Gateway, and this is where the crew will live. Right? And then there is also Lunar View. So Lunar View is really interesting because it has the largest windows as part of Gateway as a whole. So it's the flashy module, as I like to call it. But it also does provide ways for us to capture stunning images, right, of the lunar surface. And some other call outs here, I do want to mention Orion. So Orion, it is the spacecraft that will carry the crew up to Gateway. And that is the place where it's also connected to the European Service Module. So I'll talk about that as well. But before I get on that, Lunar Link. So Lunar Link is also another development from the ESA. It enhances our high data rate communications to be able to communicate with mission control here on Earth, as well as communications on the lunar surface. So I really wanted to highlight the contributions of ESA because it really shows the international collaboration that we have when it comes to the Gateway. In addition to NASA, which is, of course, our space agency for the United States, ESA, you have JAXA, so Japan, Canadian Space Agency. So there are so many different players for this effort in order to bring us to our next stage of what we call humanity. So Orion and the European Service Module. So the European Service Module, it does provide propulsion, water, oxygen, so many different elements that are needed for our crew to be able to survive, even the duration up to the Gateway. So I think that the collaboration that we have here today and the collaboration that we will continue to have in the future is only the start. It's only the start of what we're seeing as our next phase of living in our solar system. So another point that I wanted to bring up as well is this. Where we see Europe and countries like Sweden playing a role, it is truly bringing in the unique capabilities and technologies that are needed, and also the footprint of what we call diverse representation when it comes to contributing ideas from different cultures, from different backgrounds, and coming together to create something really special for our next phase of humanity. So in the long term, Gateway, it will act as a lab, a fuel depot, a staging platform, and all of these different things. So when we do return to the moon through Artemis, this will be the place where some will call home and some will call a gas station. You know, my favorite part about space programs is truly the innovations that come out of it. Yes, the destination is very cool, the end product is fantastic, but the innovations that build up and the innovations that we benefit from that comes out of the pathway, the journey there, is ultimately my favorite. So I had to just include some reminders here of why the space program is so important. So, going back to the Apollo days, the Apollo guidance computer. If you look at that core rope on the left side, those little elements of wire, there were actually women who were very skilled at sewing, right? They would actually be sitting at the table, creating those different elements to then feed the Apollo guidance computer. Well, that was the early stage of what we now call a smartphone today. That was the budding technology to bring us to where we are. But I'll also like to mention that the smartphone that you have in your hand is more powerful than what powered that very Saturn V rocket that you're seeing there in the middle. So our possibilities are astounding today compared to what you would see in the 60s and 70s. Radiant barrier insulation. So this is another invention that came out of the space program. So of course this technology was really created in order to protect our astronauts from any radiation as well as heat. Well, this has now transferred into home insulation. So what we see today, you know, it had an origin story. It had that origin story of being able to meet the requirements of what was needed in order to get to space, but definitely return from space as well, and also help us with our homes. And I want to talk about water filtration. So water filtration is absolutely important when it comes to traveling to space. You're always tied up on space, weight, all of these different things that we may take advantage of on Earth. You have a very small compartment of items that you're able to bring with you. So having a water filtration system versus having a humongous tank of water, it is in your best interest in order to reduce costs and also give you the resources that you need to survive. So the electrolytic silver ion cell, so that was the water filtration system that played a huge role in the Apollo days. And it has actually evolved to a full water filtration system that we use today. So as you're looking at the different life cycle support systems that have been able to fuel astronauts so that they have the liquids that they need in order to maintain in space, just know that what comes out can now come in. And that is a key feature of how we're able to reuse water today. Medical telemetry. So this is a big one as well. And now, you know, one of the projects that I also did at MIT, I had to tether my professor in the gym. I know that's a really awkward start, but I had to tether him in the gym in order to figure out, well, how can astronauts rotate in microgravity environments? What are the best means of rotation? So he's tethered to the gym, and I had to use all of these different patches in order to test his heart rate, his blood pressure, his temperature, all of those different elements, and that was medical telemetry. And so I'm happy to say that he was actually an astronaut. He was a former astronaut, astronaut Jeff Hoffman. Thank you, sir. And that research was able to teach me about, well, what are the elements that are needed in order to really understand and track the human elements of the body. So that was fun research, one, but then also two, it led us to some more modern technology, which is the remote health monitoring systems that we have today. So think about the sensors that you can wear at home that can track your temperature, your heart rate, and your blood pressure. That originated from the space program. So at this point, we've talked about all sorts of innovations that have developed as we were looking towards the moon. And, I must say that even as we were looking towards the moon, we were also at a point of thinking about Mars. Has anybody heard of Wernher von Braun? Haha, fantastic. Very knowledgeable audience. So Wernher von Braun, he was an innovator for rocketry. And he had this book, and it was showing the Saturn V rocket. If you look at that rocket, you can tell that it may be a little bit overbuilt to get to the moon. We've had our eyes on Mars ever since then, ever since the 50s. And so as we innovate to Mars, I want you to think about all of the innovations that have come towards this entire journey into now, and also think about the innovations to come after. So MOXIE, so the Mars Oxygen In Situ Resource Utilization Experiment. So for the MOXIE, it's this box. It is on the Pathfinder, and it is currently journeying on the Martian surface today. So it has completed about 16 missions so far, and it has generated a total of 122 grams of oxygen. So that is about 10 hours of a small dog breathing, but hear me out. It is proving that future capability is available. It is the stepping stone. You have to start somewhere in order to get to where you need to be. And this is what MOXIE is doing. So the next step, it is to create a full-scale system. So it'll be MOXIE plus liquefying. So what would liquefying do? At this point, you're generating oxygen. You liquefy the oxygen. You can then create rocket fuel, that's one. But then also, if you add in some hydrogen, you can actually recreate water. So this is a stepping stone to moving in the right direction on how we'll be able to live on Mars. And okay, everybody's talking about AI. I had to include AI in here, artificial intelligence. So right now, we are using the AI navigation system, but I must say that the possibilities with AI are well beyond just this one case here, and I think we all know that. But with the navigation system, we are able to autonomously navigate complex terrain, which is deemed as the Martian surface, as well as build 3D maps. And those 3D maps can then in turn better inform us how we can both navigate that terrain and live on that terrain. And as we're looking at the capabilities of AI, we can think about navigation systems, but I'm sure that you all can also think about so many other applications, just thinking about, well, what do we use today on Earth, right, for AI? Mimic that on Mars. All right, so ESA, Mars Express. Of course, I had to go back to European Space Agency. So the Mars Express, it was Europe's first mission to orbit Mars, studying its atmosphere, its surface, its subsurface, and Aspera 3 was an instrument on board Mars Express. And it revealed how the solar winds erodes Mars' atmosphere, shaping our understanding of the planet's climate loss. Why is that important? We want to understand the Martian history so that we know what's available to us as a society. So I wanted to also bring up the S-Range Space Center. So in my learnings, I see that for S-Range, there is now capabilities for orbital launches. I think that this is a great stepping stone for increasing our communications ability by being able to launch satellites into space. So considering that this is also in the backyard, I wanted to bring this up for everyone's attention. In Hydromars. So we've talked about the importance of being able to recycle water in very space-constrained environments. Hydromars is a really great stepping stone towards that. It's near 100% purification of water, and it's adaptable for clean water access also in remote areas here on Earth. So it's not just a Martian application. It is also beneficial on Earth as well. Okay, so I've told you about a handful of different innovations that are bringing us to Mars, but I know the question comes up, why Mars? Out of all the planets in the solar system, why is Mars the place for us to go? What is the benefit? Aside from being the fourth planet from the sun and having this red color being really cool in science fiction applications, Mars actually has some elements of what we would need in order to live, such as hydrogen, such as nitrogen, such as small amounts of oxygen that we would be able to generate in order to create a living environment. So it has potential. I know I keep saying potential, but potential is at the start of something that is possible. Orbital characteristics, so it's over 200 million kilometers from the sun, and it is approximately 2 Earth years, so you're automatically younger, right? That's a benefit. The rotational period, 24.6 hours, more time in the day to sleep. And you also have seasonal changes like you do on Earth, although the lower temperature of Mars can get down to about negative 150 degrees Celsius. But on the flip side, it can get up into about 23 degrees Celsius, so it balances it out. From a gravity standpoint, it's about a third of Earth's gravity, so you also weigh less. So see, there are benefits that directly impact you today. So I think that is very appetizing to go to Mars. So geography and surface. What's really astounding about the view of Mars' surface from afar is how smooth it looks. When you look closer, you see that it actually has the tallest volcano in the entire solar system. It's 3 times the height of Mount Everest. But what does this tell us, right? Of course, it tells us that there's intense volcanic activity, 1, but then 2, it has lava tubes that we can utilize as habitats and other resources that we would need to survive. It also has the most immense canyon system in the solar system as well. Now, I will just simply tell you that it's bigger than the Grand Canyon, but I have to give you some sizing, okay? So it extends beyond the United States. So it's humongous. It's humongous. But what can those valleys and trenches tell us? Water flow. Way, way, way back in the days, at some point, there was some water flowing on Mars. That is what that geographical element tells us. Potential. Mars moons. I wanted to bring up the moons, so it's Deimos and Phobos. I wanted to bring those two up because I know that I've talked about Lunar Gateway, and that being a gas station, right? Remember that? Well, Phobos being one of the larger of the 2 moons, for Mars, it can actually be a gas station as well. So the orbit for this one, it's about 7.5 hours is how long it takes to orbit Mars, and that moon, it can actually play as another stopping point, another gas station, another resource regenerator, another place that can enable us to live on the Martian surface. So think about what we're doing today. We are setting up our moon, the Earth's moon, as a gateway, a gas station, a place of stoppage for astronauts that are moving towards a deeper space. Imagine what we can do with that moon. Innovation is at our fingertips. And of course, there have been several robotic missions. One that I really wanted to highlight, though, Pathfinder. So Pathfinder, it is the one that I like to call a little bit flashier than the previous because the imagery is enhanced compared to what we've seen before. And we cannot forget the Ingenuity helicopter that did that really cool fly on the Martian surface, just telling us about the capabilities of autonomous flying vehicles on that surface to come. All of the different missions that we've had in the recent past and even before then, they all tell us something different about the Martian surface. We're learning, we're understanding, we're creating the blueprint of what we would need in order to set an entirely new phase of human history. And I want you guys to be a part of that. So as we think about the potential for life, I want you to look at this image. You can see how the water used to flow through the valleys of Mars. And there is evidence of just former liquid water, former water-formed materials, all of these different pieces of history that are flowing through these valleys today. And then methane spikes. So any of our biology enthusiasts or geology enthusiasts, you know that any sign of methane can be a sign of life. What life would that be on Mars? Would it be that slight microbe that gives us an inkling for what the past used to be? Or something more? Do I believe in aliens? Not exactly. However, if there is any sign of previous life, whether it's some small living organism that used to crawl around the Martian surface, I would want to learn about it. So Mars, it is important to science. It is important to understanding the whole makeup of our solar system to better understand Earth, one, with it being our neighbor, but also to better understand what our opportunities are. Mars is not just the flashy red planet. It's not just the place with the huge volcanoes and valleys. It is not just the favorite planet for all of your sci-fi movies and TV shows. It is our opportunity for a new environment, a new phase in life. So let's talk about the human element. So as we're talking about the Mars generation, I threw out some different steps for the Artemis program, right? But I didn't really throw out dates. So let's talk about it. So by 2030, we are looking to step foot on the moon again. Beyond that, we're heading to Mars, right? And so the generations that you're raising up today, and maybe even yourself, could be taking those first steps on Mars. So as part of my mission and also my husband's mission, through Rocking with the Fletchers, we spread the news that if you can dream it, you can achieve it. And if you want to go to Mars, you can do that too. So we do a lot of outreach for students, adults, you name it, but ultimately in order to spread the news that if you can dream it, you can achieve it, and we can teach you about aerospace along the way. I wanted to bring that up because as we're talking about getting ready for Mars, we have to get the people ready, right? We have to get the people ready to grasp what this living situation could look like, but also prepare our young humans to thrive in that new environment. So that is a primary mission that we have through Rocking with the Fletchers. And of course, we can talk more about it during the speakers lounge and just chat it up. And I can also share our different books that we've written as well, if you're interested in those too. So lessons for every innovator out here. So whether you are creating software in order to enhance the way that we look at our data, whether you are creating websites, whether you are creating systems in order to enhance the water flow for your community, whatever it may be, we all have a hand in humanity. You have a hand in humanity today. You'll continue to have that hand for the future, especially on a new planet. So have a bold vision. So define your beyond. We've been talking about to infinity and beyond. What does that beyond mean? We know that infinity means limitless, but what does beyond mean for you? Define what that is. Relentless collaboration. One of the cool components of the space program, it is collaborating. We talked about international collaboration, for goodness sake. So don't let location stop you. Don't let a different skill set stop you. Don't let a culture stop you from being able to collaborate and create something beautiful. No one explores alone, especially not Mars. Don't go by yourself. Please don't do that. I did not instruct you to do that. Collaborate, be a team in everything that you do. Resilient curiosity. Don't stop asking what if. Remember, what if is what started humanity in the first place, right? Our civilization. If we never asked what if we could fly, how would I have gotten here today? Oh my goodness, just imagine that. Wow. If we've never asked what if we could walk on the moon, how would we know what else is out there? If we've never asked, what if we could call another planet home, what would we be talking about today, right? Like, wow. So I wanted to leave these tokens with you, not just to think about Mars truly, but to think about your next stage of innovation, to think about your why. It always comes down to the why. Why are you doing what you're doing today? Why will you do what you're going to do tomorrow? Think about your why. So Mars is the destination, but innovation is the path. And together, we can go beyond both. So I invite you all to jot down your journey, follow it, and enjoy it. Thank you, everyone. I appreciate you all for listening to my talk, and I look forward to meeting some of you. And feel free to scan the QR code. You'll be able to follow me. And if you want to purchase one of my books, you're welcome to do so. But looking forward to being connected. Thank you.